Chairman Moses, Plant Manager of the Anderson Foundry of ABC Rail Corporation. I'd like to take this opportunity to welcome you to our open house. Many of the employees at the Anderson Foundry of ABC Rail Corporation for some time now have expressed a real interest in having an open house. It allows for our family members, friends, community neighbors, and many others a chance to see what we do. Many of the employees have put forth special efforts and have directly participated in the preparation of this open house. So that you can better understand our plant operations, a video has been made showing our plant in operation. Through this video, we hope to illustrate to each of you how our products are made. In fact, the video itself was prepared by some of the employees themselves. To give you an idea of what we make, our facility produces manganese steel castings. We are the largest producer of in-track railroad castings in the United States. The product from this plant goes to our other plants, in which they assemble our product to rail and ship directly to the ABC Rail final customers. Being that we are suppliers to the railroad industry companies, some of ABC Rail customers are Conrail, Burlington Northern, Norfolk Southern, and Santa Fe. At the end of this video, we will arrange group tours for each of you to walk through our plant. Tour guides will take you through our plant in a fashion similar to what you will see during this video. We ask that you stay with the group during the actual tours. If you have any young children accompanying you, we'd also like for you to pay special attention in keeping a watchful eye out for their safety. Due to our heavy machinery, product, and various below-ground equipment throughout our plant, they may need some special guidance. Your tour guide will try to answer any questions you may have. If he or she cannot, they can direct you to our information center we have located in the Sand Lab at the end of the tour. We also have some refreshments and snacks arranged for you at the end of the tour. We wish to thank you for coming. Please enjoy the video of operation and your plant tour. In addition, I would like to express my special thanks to all the employees who have helped in putting on this open house. I look forward to seeing all of you during your visit.
Our first stop in the production operation begins with a dimensional check of the pattern in the pattern shop. During this operation, we determine if the pattern equipment meets our prescribed tolerances. With the pattern inspected, the necessary modifications and repairs can be made. Once completed and released for production, the pattern is taken to the mold making department according to the daily schedule. In mold making, the pattern is placed in a drag flask and covered with the sand mix. The sand mix consists of olivine sand blended with a liquid binder and catalyst. The mold walker compacts the sand mix, which later air cures to form a hard mold cavity capable of containing molten metal at temperatures over 2600 degrees Fahrenheit. The bottom plate is clamped in place and completed drag is rolled over. Once rolled over, the top plate is removed and the cope or top half of the mold can then be prepared. In the next operation, the coat portion of the mold is being set by the molders with the necessary rigging that will enable the cavity to be poured with metal. Once completed, the mold is brought back under the sand mixer to enable the coat or top portion of the mold cavity to be formed. Here the coat flask is being filled and walked to compact the sand mix. Once completed, the mold is then transferred by an overhead crane to the mold closing department. Along with making the mold cavity using the pattern, certain areas of the casting must be cored out. These cores are made in the core room. Here you see 2 boxes being filled with sand. The sand mix is similar to that used in the mold making department. After the sand cores have been removed from the wooden boxes, they are smoothed out and a refractory coating is applied to provide a smoother casting surface. Then the cores are loaded on a plate for transport to the mold closing department, where these cores will later be placed in the mold. At mold closing, the cope is removed and then the patterns are stripped from the drag. Portions of the mold cavity are sprayed with the same refractory coating used in the core room, and then the cores are set. Here you see oval-shaped cores that are set to make the holes for bolts that hold the rails to the casting. After the cope has been similarly prepared and the drag is finished, the cope is brought back and the mold is closed. The cope and drag will later be clamped tightly together in preparation for pouring. The next operation is melting, and the first step in this operation is charge makeup. The charge bucket is filled with scrap metal and alloys while sitting on a scale located below floor level in the charge house. The charge bucket will then be moved from the charge house to the melting area on a transfer car. You're watching an 8-foot diameter electric arc furnace preparing to tap about 16,000 pounds of molten manganese steel. Prior to tapping, the metal chemistry was verified by spectroanalysis. The electric arc furnace melts the charge by the radiant heat of the 6,000 degree Fahrenheit arc that is struck between the graphite electrodes and the metal charge. The manganese steel alloy being produced here is tapped at about 2,700 degrees Fahrenheit into a ladle lined with refractory bricks. When the tapping is complete, the operator takes a temperature reading and the ladle is moved to the pouring area. Meanwhile, a sample of the ladle metal is analyzed to confirm that the chemistry is in spec. The next step is pouring, but prior to pouring, the mold clamps are checked to be sure that they are tight, and the metal temperature is rechecked in the ladle. Pouring temperature is very important to casting quality. You see the lever being moved that raises the stopper rod of the bottom pour ladle, and the metal comes out of the bottom. The man on the left is taking a stream temperature. After pouring, the mold is allowed to cool at least 2 hours before it is taken through the next stage, which is shakeout. At shakeout, the casting is separated from the mold sand by vibrating the flask. The sand goes to the sand reclamation, and the casting moves to the burning station where the rigging, risers, and gating are removed. After rigging removal, the castings are cleaned further and then loaded onto a heat treat car. When this load is completed, the car will be run back in the furnace and the heat treat cycle for manganese steel will be performed, which is to hold the castings at 1950 degrees for about 4 hours, followed by water quenching. You're watching the quench operation. From the time the furnace door starts up until the castings are underwater is held to 2 minutes or less. This rapid quench is what gives the unique properties to manganese steel of toughness and high wear resistance. You see the furnace and his helper now. They have passed rails underneath the load between pier blocks that hold the castings off of the bed, and now they're hooking chains to these rails so that the overhead crane can transport the load into the quench tank. After quenching, castings are shot blasted to remove any remaining sand and heat treat scale. Here you see a rail-bound frog entering the shot blast equipment. This operation is important to enable visual inspection of the casting. After shot blast, the castings will proceed to the arc grind booths for air arc removal of fins and gating. You can see it at the parting line, which is where the coke and drag meet, is a common place for fins. After air arc removal, grinding is used to contour the casting surface. Next operation is pressing. After arc grinding, castings are press straightened in preparation for planer grinding. Here you see the hydraulic ram making contact with a rail-bound frog to straighten the casting. The planer grinding operation removes finish from the running surface and flangeways in preparation for explosive hardening, which is done in Danvers, Illinois by Donovan Demolition. Explosive hardening pre-hardens the wear surfaces before installing in track for improved service life. After planer grinding, castings are radius ground and finishing, and then moved to final inspection where the castings are dimensionally checked and gauged to specified tolerances. Once the final inspector approves the casting is released in the computer system for shipment, and castings are stacked in the shipping area awaiting shipment by truck to our customers. Here you see workers loading a truck. Next, I want to show you an example of a rail-bound frog casting in service here in Anderson on the Conrail tracks. We're looking from the heel towards the toe end of a rail-bound frog. The white or shiny areas are where the wheel makes contact with the casting. I want to thank you for your attention, and I hope you enjoy your tour of the ABC Rail Anderson plant.